Okay, so thank you, Jean-Baptiste, for the invitation to present the Yuburn program. So I'm Cyrielle Denjean. I'm a researcher at CNRM. So it's a joint laboratory from Météo France and CNRS. And I'm going to present you the Yuburn program, so which means the Southern Europe Biomass Burning Project. So this title is quite restricted. One part of the project is dedicated to the understanding, to the forecasting, to the monitoring of biomass burning aerosol and gases, but half of the project is also dedicated to wildfire danger and forecast. So this is why I'm here. So I think everyone here knows the situation of wildfire in the world, but since I'm the first one, I present the situation in Europe. So just for the story, this project was built after my observation at a mountain site in the Pyrenees, at Pic du Midi, of absorbing aerosol, long-term monitoring of absorbing aerosol, so the aerosols that warm the atmosphere. And I observed during this long-term monitoring that most of absorbing aerosol comes from wildfires in Southwest Europe. So this is why I decided to build Yuburn, that was at first a small project and now becomes more and more larger. And so this observation were performed between 2019 and 2021. And what you can see in this figure is that there is an evolution in burn area in Europe due to wildfires. We observe an increase of this burn area. So it's not that there are more wildfires, it's that wildfires become more intense. And there is also an evolution in the season of wildfires. Now it doesn't only occur during summertime, but also in spring and autumn. And you can see in yellow that 2025 is a devastating year in Europe, with more than 1 million of hectares burned in Europe. So these wildfires were mostly occurred mostly in Spain and Portugal. So you can see it here in yellow and orange. So it's the emissions estimated by CAMS. So it's a European monitoring service that assimilates satellite observation in a model, in different models. And you can see that most of wildfire emissions come from Spain and Portugal compared to in dark red in Europe. And in France, it was also a terrible year where one of the worst wildfire incurred in southern France that burned an area size of Paris, caused one death and different disaster in terms of ecosystem and people. So wildfires have both direct and indirect impacts, so that cause different environmental, health and socio-economic damages. The most direct impacts are due to their spread on the ground, that cause impacts on people's lives, on infrastructure, on ecosystems. But they have also indirect impacts on air quality, earth, weather, climate and ecosystems, due to their emissions of gases and aerosols in the atmosphere. Due to climate change, the temperatures are on the rise in the world, and especially in Europe, that cause a dry out of soils, an evolution of the vegetation type. So I already presented you that an extent of the wildfire season and an increase of the intensity of fires. And in addition, wildfires are unique in that they release greenhouse gases and absorbing aerosols that contribute to the warming agents to the atmosphere. And so this creates a feedback loops with warming temperature, an increase of the intensity of fires, of the wildfire season. We release more greenhouse gases and absorbing aerosols, etc., etc. However, these impacts are very uncertain today. We still have large uncertainties in the knowledge how these wildfire impacts health, climate, air quality. There are still uncertainties in the forecasting of wildfire behavior with forecasting models. And this is due to, I think, some missing observation that allow to understand the processes behind these impacts. And especially in Europe, we missed some international coordination to exploit the potential of integrating ecological, fire, and atmospheric research to work together and to improve this knowledge and to develop new tools. So this is the reason why Yuburn exists. So the goal of Yuburn is to conduct high-impact research on wildfires and their atmospheric impacts in order to develop new observational modeling tools for preventing, monitoring, forecasting, and mitigating risk associated with these events in southern Europe. So, as I already said, at first it was a little project. So it was funded by the French research agency with a young researcher project. So it was only 2 labs, 2 research institutes with some national services and Météo France. And then it evolves. We propose another project. So the first one was only dedicated to deploy a research aircraft to sample biomass burning aerosol. So we had few flight hours to sample and characterize smoke plumes. And then we proposed another project to fund another research field campaign. I will explain you later why. We also proposed a region project that was funding. And it continued to evolve. There are different other projects that were selected. So it allowed to involve more partners in Spain and in Portugal, but also a first firefighting agency, which is very, very useful for the project to obtain new data and also to allow that the tools that we will develop will be used by operational services. And then we proposed a European project that was selected, Yuburn Risk, and that allowed to develop again the partnership, which includes then so atmospheric research, fire researchers, ecological researchers, meteorological centers, firefighting, air quality, forest protection agencies, regional governments. And we didn't stop. Then we were selected by the French Spatial Agency, and there are still other projects that are submitted and for which we wait for the funding or not. So now we are more than 30 partners that really that combine public and private research, private actors, research institutes, meteorological centers, and different firefighting agencies. So the goal is not that to be the more, and it's not just we need to be as numerous as possible. Each institute, each labs, each company will provide their own expertise that will allow to investigate and to develop solutions based on science for key areas of wildfire management. So we plan to improve the prevention of wildfires, its monitoring, its forecasting, and also a very important part of the project is the communication, because with communication we can transfer the scientific results to public and private sectors, to the stakeholders, and to civil security. And to do that, we need to understand. We need to understand what caused the wildfire spread, what caused their impacts on air quality, on climate, etc. So we really need to improve knowledge of the processes and the interactions between biosphere, wildfires, and the atmosphere. So I will develop you that now. In terms of prevention, we have 2 big tasks. The first one is on the identification of critical risk areas, which allow to support governments to propose restrictions or temporary public land closures, but also to support operational firefighting activities. So we plan to work on the fire danger forecasting systems and especially two types of forecasting systems. So those that allow to predict likelihood, but also severity of extreme events. For example, we plan to improve knowledge of vegetation flammability in the territory. It depends on the fuel type, of the fuel moisture content, etc. And also to work on the leaf fuel moisture content. The second task is on the exposure of firefighters and population to smoke. So the goal is to improve the management of firefighter exposure to public pollutants, but also to support civil protection actions and evacuation orders. So we have two main objectives. The first one is to improve knowledge on the smoke toxicity, especially to investigate the oxidation degree of particles. That is a good tracer for health impacts. So we plan to sample pollutants directly on wildfires when they are in action. And the second objective is to improve knowledge of the impacts of pollutants on the population in the boundary layer, and so to improve the spatial distribution using forecasting models that are able to forecast the transport and the concentration of pollutants. Second, monitoring. So the goal is to enhance capabilities for monitoring wildfires and their atmospheric impacts. So we have two main tasks. The first one is to use operational platform from firefighting agencies to improve knowledge of wildfire behavior and pollutants emissions. So I would say that it's a very ambitious objective. So we plan to instrument firefighting platforms, so they are airborne platforms, but also firefighters, with research instruments to monitor so the wildfire behavior and the gases and the aerosol concentration and their properties. And there is also a second objective that is to use a machine learning approach to provide near real-time information on the fire front dynamics and its development. The second task is on the long-term monitoring stations, the use of long-term monitoring stations for surface and atmospheric conditions. So we plan to coordinate and to enhance these monitoring platforms that allow to monitor soil moisture content, but also the impact of wildfires on the atmospheric compositions. So we will use and reinforce European atmospheric research facilities. So for those that know it, it's Actrice, IAGOS, ECOS. We will also use national meteorological centers platforms, Météo France, AMF, IPMA, and also we will use air quality monitoring networks in France, Spain, and Portugal. Third objective is to develop new monitoring tools based on new generation of satellites. So it's something that has already started, especially with Renan Pogam, that is in the room, and I think will present something tomorrow and Wednesday, I don't remember. So the first objective is to develop new information on wildfire location, intensity, spread, with different types of satellite, and especially MTG FCI, that is a new satellite that allows to obtain information in each 10 minutes on wildfires, but also on smoke. And the second objective is to work on the transport of pollutants with other satellites, MTG, FCI, 3MI, YASI, and NG, healthcare, that have been launched recently. Then forecasting. The goal is to evaluate and improve models and numerical tools for forecasting direct and indirect risks of wildfires. So for a task, first one on wildfire behavior, the goal is to be able to forecast the intensity and the spread of wildfire at the ground. So using fire atmosphere coupled models, so there are different ones. Meso-NH for fire, Meso-NH blaze. I think there will be presentation during this workshop about that, but also wildfire. That is, I think, an American model. Okay, so maybe there will be also a presentation of that. It's perfect. The second type of models is those that are able to forecast atmospheric composition, air quality, so especially the concentration and the composition of gases and the aerosols and how they are transported in the atmosphere. So there are at the moment two types of air quality models, CAMS Mocage in mostly center in France and CAMS Monarch on Spain and Portugal. In terms of meteorology, we want to improve the forecasting and the knowledge of the impacts of wildfires on temperature and clouds. So using a fire atmosphere chemistry cloud-coupled model. I'm an experimentator, so I find it totally crazy, but they said that it's possible. So with a mesoNH for fire ORILAM ice-free system. And finally, the last goal is on the impact of wildfires on climate. So to improve knowledge how wildfires impact the radiative budget with a regional climate model called Aladdin Climat. And so as I told you, one of important part of the project is the communication to promote the transfer of scientific results from the project to civil society. So we plan different actions. We already performed a media campaign last summer during Silex. We plan to perform a documentary film, international conference, to present the result at the end of the project to a wide audience, to media experts, etc., to write a citizen summary, and we also work on the website and social media. But to do that, all that, the central goal of the project is to improve the understanding, the knowledge of the processes that govern the impacts of wildfires. So for fires, I think everybody knows it in the room, but for fires, what is very important is to link the fire behavior to the fuel type, the fuel state, the topography, and also to meteorological conditions. And in return, all the plume characteristics, the gases concentration, the aerosol properties, it depends on the fire behavior, on the meteorology, but also on atmospheric composition. And so it's extremely important to understand the processes at the interface between the biosphere, the fire and smoke, because it will control the impact of wildfires on climate, meteorology, air quality, leaves, ecosystem, and infrastructures. And to do that, we need to have a very ambitious approach that allow to understand the processes at different scales, from the local, the fire scale, up to the territorial scale. So, for example, for the experimental strategy, we plan to perform laboratory experiments on combustion and simulation chambers, for example, to improve knowledge of how fuel flammability depends on the wind, on the type of fuel, on its hydric moisture content, etc., etc. We plan to use firefighting platforms, monitoring firefighting platforms, to obtain measurements over the fires and in its surrounding environment with the drones, the helicopters, the firefighters. There is also a task on satellite observation of fire. I already mentioned it before. At the regional scale, we have already and we will continue to deploy research aircrafts. So especially those from the SAFIR French infrastructure. And we will also deploy ground-based mobile platforms from a research laboratory, but also air quality agencies. At the territorial scale, there is a task on satellite observation of atmospheric plumes. I already mentioned it. And we plan to reinforce and use surface and atmospheric monitoring networks. And it's more or less the same strategy for modeling, for the modeling part. So with models that will allow to model and forecast the meteorological fire danger, the fire spread, the emissions of plumes, the smoke transport and evolution, the climate, and the air quality. And so to do that, we need to be, so it's very ambitious, so we need to be prepared, because it's really not easy and straightforward to perform such kind of measurements. We need to develop new instrumentation, to develop new approach, experimental approach, to be able to obtain fire behavior observation, to obtain smoke at emission. We need to develop the consortium, the partnership, to allow to perform these measurements. So this is why we go step by step. So we have 3 main steps. So the first one already started last summer. So we deployed the ATR-42 research aircraft in southern France during the Silex campaign. So I will present you a little bit the campaign and preliminary results just after that. Then in 2026, we will work with the Andalusian civil security to instrument their monitoring platforms with research instrumentation for monitoring fires, gases, and aerosols. And in 2027, it's the big campaign when we will deploy everything. So in France, in Spain, in Portugal, with research aircrafts, with mobile platform at the ground, with drones, with firefighters, with balloon, with radio soundings, etc. And so this is completed by the reinforcement of surface and atmospheric monitoring networks and the laboratory campaigns. So I take a few times to present you the summer 2025 Yuburn campaign, so that is called Silex. So it was the first urban campaign dedicated to study wildfires in Europe. So the first goal was to bring together the national expertise in fire and atmospheric science, including both experimental and numerical approaches. So the second objective was to conduct crucial technical and logistical tests to track and characterize wildfires and smoke plumes under real conditions, because as you will see, it was really not straightforward to obtain these measurements. I think 1 more month before the campaign, I was not sure that we would have any observation. And third, of course, to obtain first scientific results, first data, to support, to improve knowledge, to improve the understanding of processes, and to support the Yuburn modeling and satellite carnival activities. So it was really a real technical and logistical challenge for different reasons. The first one is that there were firefighting operations involving operational airborne activities when there are fires in Europe, in France. It's very different, for example, in Africa, where we already perform over measurements of biomass burning aerosols. And so this caused different difficulties. First is that the access to the area around the fire is normally restricted. And second, that most fires are stopped within 2 and 3 hours, so which is very good news. But when you want to sample fires and smokes, it's quite complicated. So we had different discussions with so DGAC, DGS, CGC. It's national agency that provide the authorization to flight, for example, over fires. Or DGS, CGC is a national security agency. We had discussion with firefighters, with Météo France, and with SAPIR, that is the operator French operator of a research aircraft. And this allowed, so it's 1 year of preparation, and it allowed to obtain a special flight authorization. So it was the first time that SAPIR were allowed to deploy the aircraft within 4 hours. So we were, sometimes it was 2 hours. So we were allowed to go over the fire restricted zone within 4 hours instead of the usual 24 hours. And we were allowed to fly over the flights, so over the firefighting aircraft that fight and monitor the fires. The second difficulty is that wildfires events, you know it very well, are sporadic and under-predictable, especially because they are caused by humans in Europe. So scientists develop new and upgraded new monitoring and forecasting tools, so especially made by Jean-Baptiste and Ronan in the room. So Ronan developed a new algorithm for the near real-time monitoring of fire intensity and spread based on MTGFCI data. And Jean-Baptiste was able to assimilate, no, it's maybe not a good word, but initiate for fire mesoNH, so coupled fire atmospheric model, with this new observation to forecast fire behavior. And the fact that it was the first urban campaign dedicated to the characterization of fires and smoke plumes in Europe involved that we had to develop new instrumentation adapted to these events. So we developed new systems to be able to characterize fires. So we deploy visible and infrared cameras in the aircraft. We develop at CNRM a new instrument that is called dual caps to characterize the spectral dependence of aerosol optical properties. So it's very interesting to understand climate effects of wildfires. And the LAMP developed a new instrumentation that is called MOCA to characterize the organic fraction in gas and particle phase. So it's very important information when we want to understand the formation of aerosols from wildfires. I have a slide on the wonderful monitoring and forecasting unit. So it was a team on alert every day from sunrise to sunset and sometimes more during the night. They didn't sleep a lot. But a lot of tasks to do. They were only 3, so it was quite difficult. So there are different tasks. The first one is that they present us the fire danger. So especially they participated to the Météo France and DGS CGC meetings where the meteorological fire danger was presented, and so then they plotted on figures and they presented every day to the scientists. And there was also ECMWF with Francesca. Thank you very much for providing the probability of fire, which was, I think, very useful for adapting the flights area when we wanted to go during the field campaign. For monitoring, they present us and they follow all the day the fire observation from satellites. So it's an example here with FCI MTG. But they also check the fires that monitor the smoke plumes. And we also use ground-based remote sensing instruments, so especially LiDARs from the Météo France networks and also EarlyNet and Actrice network. The forecasting and monitoring unit also presented the spread of wildfire. So here it's for fire from Jean-Baptiste, and also the transport of plumes with different models. So a first one at the local scale. So 2 models at the local scale. So it's dispersion model with FlexPart and PERL. PERL is a dispersion model developed at Météo France for operational activities. So it was very important for fires occurring in France at the local scale. And a second model that is CAMS mocage, that is a chemical transport model, so was very useful to forecast the arriving of smoke plumes from long-range transport, so especially from Canada, that was present during all the campaign in summer in the free troposphere. So it was very useful. Then they also support the flight planning. So for example, here it's an image of what we obtain in the aircraft. So from the ground, they monitor and forecast the smoke and the fires, and they draw on map the position of the smoke, the position of the fires, and it allows us directly near real time in the aircraft to help deciding where we will fly. So for example, here it's the altitude of 2 kilometers, here 1 kilometers, etc. So even if in the aircraft we had observation of the different parameters, the fire and the smoke, it was really, really useful to have, in addition, this view. And we also monitor the firefighting situation. So we had information from the briefing between Météo France and the National Civil Security on where and when they deploy monitoring and firefighting aircraft and helicopters. But also I discovered Flight Radar 24 that was very useful also to check when they send deploy some firefighting and monitoring platforms. So we were able to sample, to track and characterize wildfire and smoke over France during 11 flights. So we sampled 6 French fires, Born fires, Martigues, Sigean, Temple, and Ville-Gayenque, so in south of France. And we had also numerous sampling and characterization of long-range transported plumes from Canada and also Portugal and I think a little bit Spain, but we need to analyze the data to be sure. So there was 2 types of objective. The first one was the characterization of active fires. So you can see Ronan in the picture that deploy cameras, so visible and infrared cameras in the aircraft. So the goal was to fly over. Oh, sorry, it's in French. To fly over the restriction zone of wildfires and to characterize the location, the intensity, the FRP, the rate of spread of fires. And here is an example of a picture of results. So there was camera behind the aircraft. So this is a picture here, and this is what is obtained from the camera. So it's a reconstruction of the observation from camera in the aircraft. The second objective is the characterization of smoke. So we had 2 main strategies. The first one was to perform a straight level run in the plumes to have enough statistical data on the plume characteristics, but also vertical profiles to know the altitude of transport of the plumes, which is very important when we want to understand their radiative effects. And so we had a combination of a lot of instruments in the aircraft. It was 2 tons of instruments. So we had Institut remote sensing instrument, but also we performed offline analysis. So we sampled the gases and aerosols on grease, on filters, etc., to analyze them in the laboratory after the campaign. And so it allowed us to characterize the concentration of trace and reactive gases, but also to obtain a large view on aerosol properties, so their microphysical properties, their concentration, their size, their chemical properties, their optical properties, or they interact with radiation, and their macroscopic properties. So are they able to form cloud droplets? Is an aerosol, are smoke, biomass burning aerosol able to form droplets, and in which conditions? So this is quickly an example of what I call our golden case. So it's really sad to say that a fire is a golden scale, but for the field campaign, it was good to have a golden scale. So it's the Sigean golden scale that burns 600 hectares in south of France in end of July. So you can see here, this is the fire intensity reconstructed from the MTG-FCI satellite. And this is a picture taken from the cockpit of the aircraft by the pilots. So we arrive more or less just after the maximum of the intensity of the peak, which was really good and because we had 4 hours before arriving in the zone. And we had different measurements during the life cycle of the fires. So this is some reconstruction from Ronan of the fire behavior using the infrared camera. So it's still some data that are under processes, but you can already see some differences during the different period of the flight. And then we obtain information on the properties, the concentration of gases. So, for example, here is the CO, monoxide carbon, that is a very good tracer of smoke, and all the properties of aerosols, the size, the concentration, the optical properties, etc. And here is an example of, so this is the MTG observation, and overlaid with some measurement in the aircraft. So it's a black carbon concentration. So it's the most absorbing particles in the atmosphere, so that cause a large warming effect. And so what we did is that we were able to fly over the fires, then we fly in the plumes at different altitudes, then we come back to the fire when we fly in the plumes, and then we come back to the fire. So we have different information during the lifetime cycle of the fire. So here is the period of when we sample the fires, and this is why you observe different peaks, because we go to the fire, we go to the plume, etc. And in addition, there was post-campaign analysis with INRAE, with François team, who sampled the severity of the fire and the type of vegetation burn. So I don't have already some example, because we are still working on the data, and all is in data treatment. And also in parallel, there was some interviews with local stakeholders. So it was from the University of Leeds to assess. It's very different objective, but I think it's very important to assess the communication challenge in risk management. So it's very a collaboration with a social institute working on social. Yes, science. Thank you. Just a slide to say you that all data will be in open access for the community. So the website is created now. It's maintained by the French data service IRIS. We are currently writing the data management plan, a little bit late, but I hope it will be finished this month. And all the data are currently being evaluated, selected, and post-processed by the different institutes to provide fair access data, and so that everybody can use this data for modeling activities, for process studies, for Calval activities. And so there is the link behind here. I have just one slide on the next step. So we are still on the data treatment of the first campaign, but we are preparing the second one in summer 2026. So it's tomorrow, more or less. So it's a slide just to send you. So everything is in construction, in building, but this is an overview of what we will do in 2026. So it's the campaign will be focused on the Andalusia. So it's a strong collaboration with the Andalusian firefighting agency that is called EMA, and a different research team. So it will be a pioneer field campaign to characterize the behavior of the fires, the meteorological condition, and really the emission of smoke, but really at the fire scale. I think it would be very new and important data for improving emission inventories of smokes and their surrounding environment. So we plan to deploy miniaturized instruments for wildfires, for gases, for aerosols, on drones and balloons. And there are two steps. So in spring 2026, we will first work on prescribed burn to test the new instrumentation, because if we start directly in summer with wildfires, we can't go. I'm afraid that it will take too much time to go in the region to deploy the instrumentation, etc. So with prescribed burn, even if the smoke emission will be different than in wildfires, it will allow us to test our instrumentation and our approach. And then in summertime, we will characterize wildfires and their associated smokes. So we plan to deploy. No, we plan first to use firefighting monitoring platforms equipped with new cameras and meteorological sensors to obtain data on wildfires monitoring and meteorological conditions, and also to deploy over drones and also balloons in the plumes and in front of before the smoke transport, to have different contrasting conditions to obtain this, I think, innovating measurements. So I hope we will succeed. So it's a preparation for 2027 to be ready for the very, very big campaign. So that's it. Thank you very much. I hope I was not too long. And this is a nice picture from the experimentators, from the teams. Really, thanks for all this hard work. And thank you for your attention.